Above our heads, higher than birds fly and planes soar, there's an invisible line. This line, about 100 kilometers or 62 miles above sea level, is called the Karman Line. It's not a physical barrier like a fence or a wall, but it marks a crucial boundary. This line is where Earth's atmosphere, the air we breathe, becomes so thin that it's almost like the vacuum of space. Below the Karman Line, you're in the realm of airplanes and weather balloons. Above it, you're considered to be in outer space. The Karman Line isn't just an arbitrary point in the sky, it represents the point where the laws of physics change. Below the line, aircraft rely on aerodynamic lift from the atmosphere to stay aloft. Above the line, the air is so thin that aircraft would need to travel at incredibly high speeds, like orbital speeds, to generate enough lift. This is why spacecraft, like rockets and satellites, operate above the Karman Line. They need to be free from atmospheric drag to stay in orbit. Why is the Karman Line set at 100 kilometers? The answer lies in the physics of flight and the gradual thinning of Earth's atmosphere. As you go higher, the air pressure and density decrease. At a certain altitude, the air becomes so thin that it's practically impossible for conventional aircraft to fly. This is because there aren't enough air molecules for the wings to push against and generate lift. At around 100 kilometers, the atmosphere is so thin that an aircraft would have to travel at orbital velocity, which is about 17,500 miles per hour, or 28,000 kilometers per hour, to generate enough lift to stay aloft. This speed is necessary to counteract the pull of gravity at that altitude. Essentially, at the Karman Line, the rules of aeronautics give way to the rules of astronautics. You transition from flying in the air to orbiting Earth. The Karman Line is incredibly important in space exploration and aerospace for a number of reasons. First, it provides a globally recognized boundary for space. This is crucial for legal and regulatory purposes, such as determining which activities are considered spaceflight and which countries have jurisdiction over spacecraft. Before the Karman Line, there was no clear definition of where airspace ended and outer space began. Second, the Karman Line serves as a benchmark for space achievements. When a rocket or spacecraft crosses this line, it's considered to have reached outer space. This is why pilots, astronauts, and space tourists who have traveled above the Karman Line are often awarded astronaut wings or other forms of recognition. It's a significant milestone in human exploration. The Karman Line is named after Theodor von Karman, a Hungarian-American aerospace engineer and physicist. Karman was a brilliant scientist who made significant contributions to the fields of aeronautics and astronautics in the early 20th century. He was one of the founders of the Jet Propulsion Laboratory, or JPL, and played a crucial role in the development of supersonic flight. In the 1950s, as space travel became more of a reality, the question of where space began became increasingly relevant. Karman proposed that the boundary between Earth's atmosphere and space should be defined as the altitude at which aerodynamic lift becomes negligible compared to the centrifugal force required for orbital flight. This altitude, he calculated, was around 100 kilometers. The Karman Line, named in his honor, has since become the internationally accepted boundary of space. It's a testament to Karman's vision and his contributions to our understanding of the cosmos.